All right, guys, here starts the third part of our review for quarter one. Continuing on with that basis of what we did yesterday about solving equations, we're switching over to solving inequalities. We just have to be very careful with inequalities. They work exactly the same way, except there's an extra rule in there. Anytime you multiply or divide by a negative number, that inequality symbol right there is going to flip over. So we have to be very, very careful when we do these. Notice that the problem we did yesterday was number 17. We had this distributive problem, and then we ended up solving. Okay, this isn't much different. We have to distribute first. Okay, so we have a 2x minus 6, and then there's a minus 3x is greater than or equal to negative 1. Okay, now what do we do next? Combine our like terms. We have a positive 2x. We have a negative 3x. So 2 minus 3 is a negative x. I'm just carrying everything down to keep it simple. All right, so now we have this x here. It needs to stay by itself, which means we need to get rid of this negative 6. How do we get rid of negative 6? We add 6 to both sides. Notice we have not multiplied or divided, so we just keep this symbol exactly the same. So up here, now we have a negative x is greater than or equal to, well, negative 1 plus 6 is 5. Now we're almost done, but we still have this little negative sign. So now we have to divide. Divide by negative 1. Divide by negative 1. And here is that bells and whistles should be going off. You have an inequality symbol. You just divided or multiplied by a negative. We have to switch this. And 5 divided by negative 1 is negative 5. There you go. To test it, you can take this, plug it back into your original equation, and see, work it out, evaluate it like we did from the first day. Is it true? Does it make your inequality true? Okay. 20 is a compound inequality. Guys, this is the one which is no different than the other one, except for you have to set up two equations because you have two different symbols here. So you set up the first one. 13 is less than 5p minus 2. There's one equation. Then you have 5p minus 2 is less than or equal to 33. And you solve each one all the way out. Okay? Go ahead. We add 2 to both sides. So we have 15 is less than 5p. We're dividing by 5. Dividing by 5. Okay, so 15 divided by 5 is 3 is less than p. Okay, now we do the next side. Add 2 to both sides. So 35 is less than or equal to 5p. Well, we divide both sides by 5. So p is going to be less than or equal to, what is that? 7. Notice, we're not done. This is not the way we represent our answer. We started off as one individual problem here. So we need to have our answers not as two separate pieces, but one. So we are going to go ahead and we're going to merge all of these p's back together. So what do we type in our solution here? 3 is less than p, which is less than or equal to 7. And then we also have to graph it. So this symbol here says what? Open or closed dot? Well, the less than symbol is an open dot. So there should be an open dot at 3. Well, here's an open dot at 3. Here's an open dot at 3. Not this one. Not this one. This is a closed dot. That's a closed dot. So it's between these two. We look at the next one. This is a closed dot at 7. This is an open dot at 7. Not this one. There's your open or your closed dot at 7, and it's a line that connects the two. Perfect. Here's where we're starting to see for the first time on 21. You're going to start to see word problems and maybe a graph, and we have to figure out what's going on. So the first thing is they want to know, what are the variables? Anytime you see a graph, your x-axis and your y-axis are your variables. Okay, remember x, the independent variable, the input, it's the number you'd plug in, and y is the output. What is the... Okay? So now as you start to look at this, it's really not that bad. They want to know, what are the variables? So we just discussed it. Variables are what do your x and y axis represent? Time and board length. Cutting a board. So the whole graph is cutting a board. This is the board length. That's the time. So what does the value of the graph? What are the variables? Time and cutting the board. Okay? Because for every unit of time, when you cut the board, the length decreases. How are the variables related at the various points on the graph? So you actually have to read these. Please do not guess, you must read. The board is being cut in half at regular time intervals. Each time the board is cut, the length of the board decreases until the third and final cut. Does the board, it's being cut 1, 2, 3, 4 times. So it's being cut more than 3 times. The board is being cut at regular time intervals. Each time the board is cut, the length of the board decreases until the 5th and final cut, at which point the length remains the same indefinitely. So it was cut 1, 2, 3, 4, and then it remains the same. The board is being cut at regular time intervals. Each time the board is cut, the length of the board decreases until the 4th and final cut, at which point the length remains the same indefinitely. So if you read each one and look at your graph and compare what you're reading to what the picture is, you can see this was cut 1, 2, 3, 4. It wasn't cut 3 times like the first one says. It wasn't cut 5 times like the second choice said. It was cut 4 times. And the arrow means it goes on in that direction forever. Now, here's another one. This is another one that people always have an issue with. Notice there's no graph here for us to look at, but they gave us a table of values. These are our inputs. These are our outputs. From a table of values, you can determine, is this a linear function, quadratic function? What kind of function? Is it even a function? Okay. We can also get the equation of the function from this. We can determine what's the slope. Remember, slope, y2 minus y1 over x2 minus x1. That's slope. Y equals mx plus b. These are all the equations that we used. B is your y-intercept. That means when x equals 0, the y is b. And the slope is right here. It's the rise over 1, or your changes from one to the next. What is this change? 2. What is this change? 2. What is this change? 2. So we already can tell just by looking at this, every time x increases by 1, our y's increase by 2. Can we figure out what is the initial value? What is that y-intercept? When you plug a 0 in for x, what do you get for y? We do. Look, there is a 0 here. If they didn't have a 0, we could still get it. We could say, hey, if I take away 2, since this is always going up by 2, if I take away 2 from this, can I get to 1? Yeah, you can. So we could say, here's our equation. Y equals 2x plus 1. So 1 is being added to 2 times the variable. Great, let's see what this problem, I didn't even start to read the problem. I already have a lot of information. Let's see what they're asking us. The first one, represent a relationship using words. Okay, so now we have to read all these. The value of y is 5 less than the cube. This is a linear function, guys. So it's not a cube of any kind. We know it's not that one. The value of y is 1 more than the quantity of 2 times x is 1 more than the quantity of 2 times x. I think it might be this one, but let's read the other ones just in case. Cube. It's not a cube. We already determined this was a line. The value of y is 10 less than. We're not subtracting anything in here. The value of y is 10 times. No, we said the slope was 2 times. And here's again. The value of y is the square. This is not a square. So yeah, our first feeling right here, and it matched our equation. Look what they want us to do next. They want us to write the equation. We just did that. So you can transfer it down to x plus 1. Now they want you to find the graph. Well, here's your graph. Okay, we need to find a graph that has a y-intercept at 1. So this one has a y-intercept at 1. Cannot be this one. This one's at 0. Cannot be that one. So it's this one or this one. Which one is actually a linear equation? It goes up 2 to the right 1. Up 2 to the right 1. This one doesn't. It doesn't follow that. This is probably, looking at it, half of a quadratic function. So it's this one, D. Is this a function? Yeah, it passes the vertical line test. Do any of our x values repeat? Nope. And if you were to draw a vertical line, it's only going to touch once. And in addition, they didn't ask, but this is a discrete graph. Notice it's a bunch of dots and there's not a line connecting them. There we go. They want us to graph. Okay, you need to graph a thing. So when we graph, the first thing you need to do is put a point on your graph. They give you that equation, y equals mx plus b. B is your y-intercept. It is the point on the y-axis where this line crosses. So it's 4, you go to the y-axis and you put a dot at 4. Now you have to put your slope. Well, it takes you from one point to the next. That's what a slope does. Rise over run. Rise over run. That is your slope. That's m in your equation. Slope. So 2 over 1. You go up 2, so you go 1, 2, you go over 1. Again, up 2, over 1. Up 2, over 1. In Math Excel, of course, when you open it, it'll automatically draw your line. If you're manually drawing, you can keep going. But you see, I have a line here, and I'll do my best with this janky little tool I have. But there you go. Positive slope, that line's pointing up, just like Mr. Slope's eyebrows. Positive, undefined, horizontal. Remember, booger out of his nose. X equals, the tongue in the mouth, the line Y equals. Here again, they want you to graph another one. I have confidence you can do this one. Plot your y-intercept, then apply your slope, 5 over 1. Last one. Ooh, they give us slopes now that aren't quite right. I'm going to change this so it makes it a little different. I'm going to say that this is a plus 3. All right, so we go over here. We have y equals negative 3/4 x plus 3. Our intercept is 3. And we're going positive or negative slope here. There's a negative. Negative looks like Mr. Slope's right eyebrow. So we need to make sure our line is going down. So we start at our intercept at 3, and we're going to go down 3. 1, 2, 3, and over 4. 1, 2, 3, 4. There's our next dot. Down 3. 1, 2, 3, and over 4. 1, 2, 3, 4. Great. And look, does that kind of line up? Yes, it does. Too bad. Is it a negative slope like his right eyebrow? Yes, it is. There is your equation. That's it for today's review, guys. We've reviewed slope, slope-intercept, being able to identify slope and the y-intercept out of a table of values just by looking at graphs. These are things we got to get good at. All right? Thanks for watching. Make sure you get out there and finish your homework. All right?